Oh, good morning. You made it to my video explaining the Accuplacer college math test, and for the next few hours I'm going to do the best I can to prepare you for the Accuplacer college level math test. I should probably introduce myself. My name is John Grima, and I teach at the North Campus of Glendale Community College, and myself and Lisa Brown, who also is a math teacher at GCC, developed some questions to help you prepare for the Accuplacer college level math test. What we did is we took the college level math placement test twice, and then we kind of poked around online and found the online resources that were available, and then kind of did the best we could to make up a practice test for you. I have to tell you that each time that we took the Accuplacer placement test, the test was completely different. There was almost no overlap between the first test and the second test, and for whatever reason the second test felt easier than the first test. I guess that's not terribly important, but what's going to be important is I'll do the best I can to prepare you for the test, but maybe I'd have to take the test a dozen times before I could make a review that is really, really comprehensive and would kind of track the test nicely. So what I tried to do is to make up problems that kind of had the spirit of the problems, or kind of like the theory behind the problems that I saw. And so none of the problems may be exact one-for-one matches, like, oh, this problem 8 is just like problem 2 on the Accuplacer test. But I'm trying to get the skills that I needed to solve the problems, along with some of the theoretical bits of knowledge that I needed to have to get through the test. And I just wrote up some problems that I hope will make your test better than by not watching this video. The thing about the test is you don't have to get 100% on it. The test has 20 questions, and the highest score you can get is 120 points, and you only need 60 at this point to test in the calculus at GCC. So I suspect that means you need to get somewhere around 10 right to get into calculus. So you're not expected to know how to do everything, and if you did know how to do everything, then you probably would be well beyond calculus at GCC. I don't know that every question is worth 6 points. I was told that some questions are weighted heavier than others, and the guy at the testing center didn't even know how exactly your score is computed. So, but I would suspect that getting a little more than half of the questions right is going to set you up for any math class that you might want to get into. After you do my video, you might want to go to the Accuplacer website and try their practice problems too, because I figure Accuplacer practice problems have to be, worth looking at, because if they decided to give you those problems, they must think they're pretty important. So I wanted to show you the Accuplacer website and the practice test that they have available. The practice test that's available on the Accuplacer website that I'll point you to here in a few seconds. I don't have a videotape solution of it because there's a bunch of them on YouTube. If you just search Accuplacer on college math on YouTube, you'll find bunches of people showing you how to do this problems, kind of like I'm going to show you to do the problems here in a second. So I'm going to go over to my computer, and I did a web search for Accuplacer, and this is the accuplacer.org website. And if you just click on the tab that says Information for Students, when you get to that, and then on the top of the page, if you click on the tab that says Accuplacer Tests, and then you scroll down to where it says College Level Math, because that's what we're preparing for, and then scroll a little more down where it says Practice Sample Questions, you'll get the practice test that I'm talking about. You're going to get way more than the college math practice test. This link right here is going to open up a practice test for every single Accuplacer test that exists. So once you get this open, you're going to have to scroll down quite a bit, and eventually you'll get to the math questions. There's 3 different Accuplacer math placement tests, and the one that we're preparing for here is the college level math placement test, which starts on page 13. So there are 20 questions here, and they're multiple choice questions, which is what you're going to get when you take the test. And it'd be really good to practice either before or after you do this video. And I tried not to make my questions overlap with theirs too much, so that would be like kind of 20 fresh new questions for you to look at. So you should definitely try that. If you're, really confident you might be able to figure out the answers to the questions just by yourself. If not, poke around YouTube and you'll find somebody working those out for you that hopefully they do, an awesome explanation for you. Lots of ums this morning. When you go to take the test, the Accuplacer test, you're not allowed to bring a calculator. They give you scratch paper, and you can bring a pencil in. The test is 20 multiple choice questions, and you really don't have access to a calculator. Of the 20 question test, probably Accuplacer wants you to do about 16 of them completely without a calculator. And for the few questions that Accuplacer thinks you need a calculator to do some of the math, a calculator icon will pop up on your screen, and if you hit it, a calculator will come up that adds, subtracts, multiplies, and divides, but it won't do any of the trig functions or graphing. It's a really just basic checkbook calculator. So more or less you're stuck doing everything by yourself. In terms of, the calculator's just not there. And I do math pretty decently in my head. I don't even think I used the calculator when it popped up. So the test isn't designed to be, calculator intensive. It's designed to be kind of theoretical in nature, and it's, like I said, it's a challenging test, but it's obviously they want it to be challenging when you only need to get 60 points out of 120 to get into our calculus class. So I'm going to just kind of jump into this the best I can, and hopefully this helps you out. This video is going to stretch through 2 different videos because I'm a long talker. You'll get to find that out pretty quick. And I couldn't say everything I wanted to say in one video. In the first video, I'll do about the first half of my problems. In the second video, I'll finish up the rest of the problems. You'll notice that most every question has a part A and then a part B. If I was going through this video and I was you, if I looked at a problem and I thought I could do the problem, then I would absolutely just give that problem a go and run through the problem and then try to check my answer. And there are answers at the end of this. Let me open the, I didn't bring them with me, but there are answers on the last page of this. And if you do a problem, you check the answer and it's correct, then you could just not watch the video and fast forward through my video explanation and make it go a little bit quicker. If you come to a part A of a problem and you have no idea how to do it, that's kind of what I expect, watch me do part A and then pause the video, and then after I do part A and you watch it for a little and feel like you might understand the concept a little bit, then yourself, you should try part B, pause the video, try part B, check the answer. If you get the answer to part B right, fast forward, don't need to watch my video. If you get the answer to part B wrong, watch my video and see if you've kind of figured out where your mistake was. So for every problem, most every problem, there's both a part A and a part B, and the idea is try it. If you can't do it, watch me do part A, pause, do part B, and then we'll kind of go through that way. The more you can do without having me tell you how to do it, the better preparation this is going to be for you. So let me just jump into this now. So problem 1 wants me to add fractions. And in order to add or subtract fractions, you need to have a common denominator. I'm rewriting the first fraction and I'm putting the y plus 4 in a parentheses. It really doesn't need ever to have that parentheses. Well, I guess at some point it's going to need it, but it really didn't need it this early. But putting the y plus 4 in parentheses might make it obvious that the thing that's making each fraction different, or each fraction's denominator different, is the right fraction has a y minus 3 and the left fraction's denominator doesn't have a y minus 3. To add the two fractions together, they have to have exactly the same denominators, and to get the fractions denominators equal to each other, I need to get a y minus 3 in the first fraction's denominator. And when a problem doesn't have an equal sign, when you're trying to make two fractions have a common denominator, you multiply anything you multiply the denominator by, you multiply the numerator by. So now the fractions have the same denominators. We generally multiply out the numerators and leave the denominators and don't multiply them out. So generally, next, once we get the denominators to be equal, we multiply or distribute the numerators, but we leave the denominators factored. And this will help you get the answer that Accuplacer would want. So this first numerator, I'm going to multiply it out. For the first numerator, I'm going to go y times y and y times minus 3. When I do y times y, that numerator, the y times y gives me a y squared. When I do y times minus 3, it gives me minus 3y. And that takes my two fractions and makes them have exactly the same denominator, and it has the numerators written in such a way that when I combine the two fractions into one, the numerators will simplify. So now I'm going to make the two fractions into one, and when you add or subtract fractions, the denominators don't change. I just write the numerators next to each other in one big fraction. This is kind of the add part of my instructions. I've added the two fractions. I took a problem that had two fractions. I've got a common denominator. I added and created one fraction. Now I'm going to go into the and simplify part. And for the and simplify part, in this numerator, the middle terms here are the negative 3y and the positive 8y can be combined. And because the numbers in front of the y's have opposite signs, I subtract the numbers and take the sign of the larger, so that combines to be a positive 5y. So I'm almost done with the and simplify part, but not completely. This problem isn't considered completely simplified because the numerator is a factorable quadratic. So I'm going to factor the numerator. I'm going to assume that you can factor and not really explain how to factor. If your factoring skills are really rusty and you knew how to factor at one point but you've kind of forgot, if you go to my website, just search out my name on Google, I suppose, and I'll come up real quick. John Grimma at Glendale Community College. If you go to my website and you click on the tab for intermediate algebra, my chapter 1 videos explaining almost everything you can possibly want to know about factoring. So when I go from this step to the next step, go from this trinomial to the factored version of that trinomial, if you have no idea how to do this, then it could hardly hurt you to watch those videos. I mean, it could be boring as heck, but after watching my videos, which would be probably another 7 or 8 hours worth of videos, you could be a pro factorer. So I'm almost done with the and simplify part. I factored the numerator, and that gives me the ability to cancel these y plus 4s, and now I'm going to be able to write my answer. My answer is going to be what didn't cancel in the numerator and what didn't cancel in the denominator. And now that I've taken the factoring away, I really don't need the parentheses anymore. If you left the parentheses, it wouldn't be wrong. And if you left the parentheses, it wouldn't keep you from getting the right answer on the Accuplacer test, because the Accuplacer test is multiple choice. There's no way they'd have this answer and then the version of the answer with the parentheses. It's not that tricky of a test. It's not an easy test, but it's not intentionally tricky where they give you 2 answers that are the same and one form is more correct than another. That doesn't happen. So I've and simplified. I haven't talked about the where defined part, because the where defined part, it doesn't really impact the algebra that I do. The where defined part has to do with this answer and the original problem. They're equal for every value of y that's in the domain of the initial problem and in the domain of the answer. And it turns out that if you plugged -4 into my answer, and this is not that important, but this is this part right here. If you plug -4 into my answer, you'd go -4 plus 1 over -4 minus 3, which is -3 over -7. You'd get -3 over -7, which is positive 3/7. If you did the same thing and plugged -4 into the original problem, you'd get undefined. And for your answer to be said to be equal to the original problem, for any value of y that you choose, if you plug it both into your answer and plug it into the original problem, you should get the same result. And this is this qualifier where defined. So this answer, if you pick any number for y, plug it into this problem, plug it into the original problem, you'll get the same answer except for the place where the original problem is undefined. Not important at all in terms of getting the computations that you need to get. Okay, so you should hopefully pause the video and try to do part B. It's maybe just slightly harder, but it's not remarkably harder. And then if you can't do the problem, then just watch me do this. When I draw my z's, I put lines through my z's. You can already tell my writing is not really the best. And it's hard for students to tell the difference between my z's and my 2's. And of course, I wrote a problem that had both z's and 2's in it, which is not really bright. But to help you see the difference between my z's and my 2's, I toss the lines between the z's. So for this problem, it's set up structurally just like part A. The first fraction is missing the z minus 5 in the denominator that the second fraction has. So I'm going to multiply the numerator and the denominator of the first fraction by z minus 5. And generally, when we're dealing with adding or subtracting fractions, we don't multiply out the denominators, but we do multiply out the numerators. And just like I did for part A, I'm going to multiply out the numerator. And multiplying out the numerator is just distributing. I'm going to multiply z times z to multiply out the factor that I presented in the numerator and get a z squared, and multiply z times minus 5, and I'll get a minus 5z. So in the numerator of the first fraction, instead of writing z times z minus 5, I'm going to write z squared minus 5z. Now the fractions have the same denominators, so I can combine the two fractions into one. And whatever work you can do in your head, you certainly can do it in your head, because you don't need to show any work. It's a multiple choice computer test, and nobody's ever going to look at your work. When you turn the test in, you'll turn your work in and they'll shred it. But you definitely don't need to get crazy with your work. You'll notice that when I wrote this z down, I put a 1 in front of it. Anytime you have a variable that doesn't have a number in front of it, there's an implied 1. And it's hopefully make it easier to see this step, because I need to combine this minus 5z and that minus 1z together. And because the numbers in front of the z's are both negative, when I combine them, I'm going to add the numbers and keep them negative. And that will give me z squared minus 6z plus 5. I'm almost done. I've got the adding part and the beginning of the simplifying. The ending of the simplifying is to factor the numerator. This is a double minus factoring, and that numerator factors into z minus 1 times z minus 5. If you completely don't recognize factoring or remember factoring at all, then probably college algebra or higher isn't the right class for you, because in college algebra, or higher, it's just assumed that you can factor. And if you can't factor, then bad things, you won't do well. But if you saw factoring at some point and just forgot how to do it, watching my videos might be enough. So I factored, and now I'm going to cancel, and I'm ready to write my answer. So again, I'm going to not write the parentheses when I write my answer. So I get z minus 1 over z plus 2. So hopefully my writing is tolerable. I know that writing is definitely not a skill of mine. I try to write big and slow to make up for my cruddy writing, but I'm not sure that it really works. Both times that I took the Accuplacer, there were at least 5 problems, maybe 7 or 8 problems that weren't particularly hard, but weren't like anything we ever ask in our math classes. 2 would fit that perfectly. It's not hard once you see the trick, but to know the trick, I guess most students wouldn't know the trick. And I think even on the Accuplacer website, on their practice test, there's a problem that has this trick. And I'll just walk you through it. And once I walk you through part A, you should be able to do part B pretty well. So what I'm supposed to do is I'm supposed to change the k on the left side so that the left and the right side are equal to each other. How the problem looks right now, I could figure out the k, but it would be kind of mysterious. So what I'm going to do to make it easy for you to figure out the value of k that makes the left side equal the right side is I'm going to FOIL the right side. And once I FOIL and simplify the right side, it should be easy to know what the k is supposed to be on the left side. So for FOILing, I'm going to multiply the firsts, which are x times x, which is x squared, the outers, which are x times minus 3, which is minus 3x, the inners, which are positive 7 times x, which is positive 7x, and the lasts, which are 7 times minus 3, which is minus 21. To start to get the sides to look more like each other, to make it easier to figure out what the k is going to be. So I'm leaving the left side alone. I'm not going to change it at all for this entire problem. And I'm simplifying the right side. And on the right side, this minus 3 and positive 7, x are going to combine. And because the numbers in front of the x's have opposite signs, when I combine them, I subtract and take the sign of the larger. And I get x squared plus 4x minus 21. now that I look at the left side and the right side, they both have an x squared plus, they both have a minus 21. The only difference between the left side and the right side is in front of the x on the right side there's a 4, in front of the x on the left side there's a k. It must be, for the left side to equal the right side, the k must have to equal to 4. And again, that's all there is to do. It's an odd question, but it's how you answer it. Part B is the same sort of trick, but it has a little subtlety that k comes up to be negative. So when we go to do part B, if you fast forward it, if you did it ahead of me and checked your answer, you're going to you'll run into the negative, and hopefully that doesn't throw you for a loop. If it does, I'll do it for you right now, and hopefully that makes the problem tolerable. So for part B, just like I did for part A, I'm going to start off by foiling the right side. The first are going to be x times x, which is going to give me an x squared. The outers are x times minus 5, which is a minus 5x. The inners are minus 6 times x, which is a minus 6x. And the lasts are minus 6 times minus 5, which is a positive 30. So, again, you don't need to show the detailed work that I'm showing because it's a multiple choice test. Just like the last problem, generally when you FOIL, the outers and the inners combine together, and that's the case here. And in this case, the outers and the inners both have negative signs in front of them, and when that happens, you add the numbers and keep them negative. And I'm going to get an x squared minus 11x plus 30. This would be enough for me to say that k equals to negative 11, and the next step I wouldn't do, but you can certainly rewrite any problem that has a subtraction with an addition. And the rewrite of the right side to make it have a plus would be plus negative 11x as opposed to minus 11x. These two versions of the right side are the same, and the second version, usually if you have two signs connected or next to each other, you put the second sign in the parentheses. The second sign usually is a negative. So both of these are going to tell me that the number in front of the x needs to be negative 11. So my answer to part B is going to be k equal to negative 11. Okay, so hopefully you're tolerating this. I know I'm a long talker and it's incredibly dull, but hopefully at least the content is going to be useful, and you don't just hit pause and stop right now just because you're bored out of your mind. I completely understand that this is probably not the most enjoyable thing for you to do, but it's going to help if you get through this, and I try to make the problems relevant. They should definitely help you when you get to the test, and hopefully at least I make it understandable. Problems that have equal signs and absolute values generally have two solutions. And to solve 3A or 3B, I'm going to need to create two problems that I need to solve, and neither one's going to have an absolute value. Generally, when I'm asked to solve a problem that has an absolute value, I create two problems, neither of which has an absolute value. So that's what I'm going to do now. So I'm going to create two problems without absolute value signs to help me get the two solutions. If you leave the absolute value signs and you do the algebra, you're probably going to get the wrong answer, or even if you get the right answer, your math won't look that nice to a teacher. And the problems are easy. The first problem is just physically just dropping the absolute value sign and not changing anything, but just dropping the absolute value sign. So that's my first of two problems that I'm going to solve. And the second problem is almost going to look the same as the first problem. The left side is going to be exactly the same. I'm going to drop the absolute value, but on the right side I'm going to put the negative or the opposite of the right side. This is because if the inside of the absolute value simplifies to 16, when I take the absolute value, I'll get 16. If the inside of the absolute value simplifies to negative 16, when I apply the absolute value, I'll get 16. So generally, for absolute value equations, problems that have equal signs with absolute values, you create two problems. Neither has an absolute value sign. One is just a problem with the absolute value dropped. The other is the problem with the absolute value dropped and the opposite or the negative of the right side written. I'll just solve this. So I'm going to minus 10 from the left side. I'll get 2x equals to 6, and then I'll divide by 2 and get x equal to 3. For the right side, I'm going to minus 10 and minus 10 and get 2x equals to minus 26. Here the numbers have the same sign, so I add the numbers and keep them negative, and then divide by 2, and get x equal to negative 13. So when I go to write my answer, I'm going to say x equals to 3 and negative 13. Again, when you take the Accuplacer test, you don't really write the answers in really nice forms. I would guess the multiple choice answer that you'd be looking at would just have the numbers without the variables written in front of them. But again, it's not a tricky test in terms of if you have a correct answer, that's not going to make it hard to pick out the correct answer. So if you went this far, you just search out the answer that had 3 and negative 13, and there's only going to be one of them. There's likely going to be an answer that just has the number 3. There's likely going to be an answer that just has the number negative 13. You have to realize when you have absolute values with an equal sign, you generally get 2 answers. So I'm going to do exactly the same thing for part B. I might get a fraction answer, and that's completely okay. I might get a negative number answer. That would be okay as well. So I'm going to, if you're watching this, I'm going to solve 2 problems, neither of which is going to have an absolute value. First problem, I just drop the absolute value. The second problem, when I drop the absolute value, I take the opposite of the right side. The opposite of positive 2 is negative 2. And now I'll solve each. I'm going to minus 8 and then divide. So for the left side, I minus 8 and minus 8. On the left side, the 8's cancel. I'm left with a minus 3x. And on the right side, the numbers have opposite signs, so I subtract and take the sign of the larger and get negative 6. And then I'll divide both sides by negative 3 and get x equal to 2. No fraction there. Maybe the next one gives me the fraction. For my other side, I minus 8 and minus 8. The 8's cancel on the left side. On the right side, the numbers have the same sign, so I add them and keep them negative and get a negative 10x. And then I divide by negative 3, divide by negative 3. The 2 negatives divide out to be a positive, and that fraction doesn't reduce. I don't remember getting any decimal answers on the Accuplacer test, so I would definitely leave fractions, and I think they give improper fractions as opposed to mixed fractions. So this would be the kind of answer that Accuplacer would hope for you to write for that problem. On, I think, both of the Accuplacer tests, there was a system of equations, and not a particularly challenging system of equations, and the instructions told me which variable to solve for. Generally, when you have a system of equations, which would mean, in this case, 2 equations and 2 unknowns, your answer is going to contain both an x and a y, or both variables that are unknown. In this case, I'm supposed to find the value of y. That is the solution for the system of equations. You may have not seen this before. We definitely do this in college algebra, and we do it in beginning algebra on campus. And kind of depending on what math you've taken, you may have never seen a problem like this, and it's not particularly hard. So I'm going to solve this system of equations, and I'm going to get an answer for both x and y, but the final answer that I write is only going to be the answer that I get for y. I'm going to ignore the x, even though it's part of the answer to the system of equations. It's not what Accuplacer wants. the system of equations that I remember was easy, just like this is easy. So what I'm going to do is add the top and bottom equation together. When I add the top and bottom equation together, the x in the bottom equation doesn't have a number in front of it, so I think there's an implied 1. When I add 4x plus 1x, I get a 5x. When I add the top and the bottom of the equation, the y's are opposite, so they cancel. So I'm not going to write a y. And to the right of the equal sign, I'll add the 8 and 12 and get 20. If you've done systems of equations problems in the past, you know that sometimes before you add the equations together, you have to multiply one or both equation by a number. I don't remember that being an issue when I took the Accuplacer. So this is a really basic system of equations problem. And by adding the equations together, I dropped out the y, so I was able to get an answer for x. I need to now get an answer for y. To get an answer for y, I need to pick one of the equations, and it doesn't matter which, but I like to pick the equations that have positives and not the equations that have negatives, because I do math better with pluses than minuses. And what I need to do is take the value for x that I just came up with and plug it into the equation that I picked. It doesn't matter which equation, but you have to plug in 4 for x. When I plug in 4 for x, I get 16 plus y equals to 8, and then I'll minus 16 and minus 16 and get on the left side just y, and on the right side negative 8. So technically the answer to the whole system is it's the point 4 negative 8, or x equal to 4, y equal to negative 8 is the solution to the system. But if you pick that as a multiple choice answer, it wouldn't technically be right, because I'm supposed to find the value of y. And so my answer to this is the value of y that's in the solution to the system is y equal to negative 8. All right, so for part B, same thing. I'm going to add the equations together, and that's going to cause the y's to drop out. And then I'll need to finish solving for x and then do some math to solve for y. So when I add the equations together, on the left side 1x plus 1x is 2x. The y's are opposite, so they're going to cancel each other out when we combine the two equations. And on the right side, 8 plus 12 is 20. And now I'm going to divide by 2, and get x equal to 10. And again, I'm going to solve for y because I was asked to only solve for y. I got an answer for x, but I don't even need that answer. To solve for y, I'm going to take the top equation. I could take the bottom, but I like using the pluses. I'm going to change the x to 10. And I'm going to solve for y. I'm going to minus 10 from both sides. And on the left side, the 10s will cancel. On the right side, the numbers have opposite signs, so I subtract and take the sign of the larger. And the answer that they would want on an Accuplacer test to this is just y equal to negative 2. Okay, so long ways to go. And something that you may have never seen before. And that's could easily happen on Accuplacer because this is testing to see if you're ready to get up through calculus. This is something that we do in college algebra at GCC. When I used to teach classes at ASU, they didn't even do this in college algebra. They did it in something called finite math. So you may have never seen something like number 5 before. Doesn't mean you can't learn it real quickly, just in case it comes up on the Accuplacer, because it's not hard. Again, so if you've never seen this before, you'd have no idea what to do. It says find the value of x for the following determinant equations. And these lines that look like absolute value symbols are called determinants. And a determinant is a number that's associated with something called a matrix. Again, I don't want to get too crazy with my explanation here. But in order to simplify the problem to make it understandable, I need to get rid of these determinant signs. And to get rid of the determinant signs, I have to cross multiply and subtract. So my first step is going to be to get rid of the determinant signs by multiplying down the main diagonal, we call that, and multiplying up the main diagonal, and subtracting the results. So I'm going to put a subtraction sign between. So this equation has the same meaning as the original problem and it doesn't have the determinant sign. Now I'm going to physically do the multiplications that I cross multiplied. 2 times -1 is -2. X times 5 I can write as 5x. Keep the minus sign between them because dropping the determinant sign is cross multiplying and subtracting essentially. Probably cross multiplying isn't the best word to use, but it's kind of, hopefully makes sense. I'm going to add 2 to both sides. When you do that, you get minus 5x equals to 10. I'm almost done. I'm going to divide by minus 5, divide by minus 5, and you get the answer of x equal to minus 2. If you're lucky enough to get this problem and you remember how to do it, this could be the difference between you testing into intermediate algebra and testing into college algebra. Because like I said, you don't need that many problems right to get into a reasonably high math class. So hopefully this inspired you enough to do part B. Hopefully this marker looks different because I pulled out a different marker. I like using lots of colors for, I don't know why, I just like colored markers. And a lot of times they don't show up so colorful, or you can't tell the color so well, which is kind of disappointing. So I'm going to do the same thing for part B. I'm going to cross multiply kind of down and get 3 times x. I'm going to cross multiply up and get -3 times 4. And I have to subtract the results. And that allows me to drop the determinant sign. And now I'm going to just solve this. The 3 times x I'm going to write as 3x. Here I have a double minus, which is going to turn to a plus. I'm going to multiply that minus. I'll do the minus of minus 12 and get a positive 12. Rather than writing minus 12, I'm writing a positive 12, which is better. So that cleans up the left side. The right side is 24. Now I'm going to minus 12 and minus 12. That's going to give me 3x equals to 12, and then divide by 3, divide by 3, and you get the answer of x equal to 4. So hopefully I'm not driving you crazy, going too slow for you and showing too much in the way of steps. I generally don't skip a lot of steps, and on a video like this I definitely didn't want to skip a lot of steps because I'm assuming there are some of you that haven't had math for 15 or 20 years, and if I skip one step it might be the step that kills you. So I try to show too much, which, for some students they hate it, some students love it, so hopefully you're just kind of tolerating what I'm doing this morning. 6, I have to write down some rules, because in order to do 6 right as a single logarithm, I have to know, well, for this problem, 2 rules, and then for part B, a 3rd rule. So some rules of logarithms that are going to come up in the second video as well that you need to remember. So we need to know 3 logarithm rules, and there's probably more than 3, but these are the 3 that we consistently use to do this problem. If you've never seen logarithms before, this is probably another one of those areas where you might be able to sneak something right on the test without having a deep understanding. And that's okay, because we don't introduce logarithms until college algebra. So if you wind up getting this problem right, or if you get a problem like this on the Accuplacer and you get it right, it might help you get into college algebra, which is a great thing. So the first rule I'm going to call, and I'll be kind of dumb in my words here, but maybe it'll be good for you. I'm going to call it the multiply to exponent rule. Sometimes I call it the product to power rule. And I'm going to write what the rule says theoretically, and then how it kind of fits to this problem. The multiply to exponent rule symbolically says if I have a number written in front of a logarithm, regardless of what the base and what the argument is, that number that's being multiplied, this is n times the logarithm base b of x, that number can be brought inside the logarithm if I make it an exponent of the argument. So that's the rule I'm going to use. So for an example of how that rule would apply, like if I had 3 times the log base 4 of z, that would be the same as the log base 4 of z cubed. So now I'm going to get back to the problem, or get to the problem that I'm supposed to work at, which is problem 6a, and I'm going to apply that rule, because that's the first of the 2 rules that I'm going to need. So to write something as a single logarithm, if there's numbers written in front of the logarithms, those numbers are multiplied by the logarithms, I need to use the multiply to exponent rule to make the logarithms not have coefficients. So I'm using it for both logarithms, and I'm leaving the minus sign between the logarithms. So that's the first rule that I need of logarithms. The second rule that I'm going to need for logarithms is the minus to divide rule. A lot of times I say difference to quotient rule, but I don't want to get that wordy. And the minus to divide rule, again, abstractly says if I have 2 logarithms that have the same base, and there's a minus sign between the 2 logarithms, that I could rewrite those 2 logarithms as a single logarithm. There's the minus part of the minus divide rule, and here's the divide part of the minus divide rule. I could take 2 logarithms and write them as a single logarithm, provided the logarithms have the same base. If they have a minus sign in front between them, when I make the 2 logarithms into 1 logarithm, I divide the arguments. Again, abstractly, for something like this, if I had like something like the log base 5 of y to the 4th minus the log base 5 of z, the minus to divide rule would say those 2 logarithms can be written as a single logarithm, the log base 5 of y to the 4th over z. That's the rule that I'm going to need to finish this problem, because in the problem that I'm just about to do here, I'm asked to write as a single logarithm. To write something as a single logarithm, you have to use anytime there's a multiplication in front of our coefficient in front of a logarithm, you need to use the multiply to exponent rule. And then once you use the multiply the exponent rule, you have to figure out which rule allows you to make the 2 logarithms into 1. And for this problem, the rule is the minus to divide rule. That's going to be the answer to 6a. When I move on to 6b, I have to introduce one more rule, and that's the plus to times rule. And it's essentially the same rule as the minus to divide rule, but instead of having a minus sign between the logarithms, you'll have a plus sign between the logarithms. And when you combine the 2 logarithms into a single logarithm, instead of dividing, you're going to multiply. And again, an example, so this is the rule written formally, the log base b of x plus the log base b of y equals the log base b of xy. And then more practically, if I had something like the log base 2 of x squared plus the log base 2 of y to the 4th, this would be the log base 2 of x squared y to the 4th. So those rules you have to know to be able to do this problem. And then on the second half of the video, you're going to have to know how to use the rules backwards to do another problem. with the same three rules again that will pop up, or at least two of the three rules will pop up, but we'll use them backwards. And it's not particularly hard, but I'll not explain how to use them backwards until we need that. So when I dig into 6b, I'm going to do essentially the same thing that I did for 6a. The first thing I'm going to do is use the multiply to exponent rule to rewrite each of the logarithms so they don't have coefficients. The first logarithm I'm going to write as a logarithm base 3 of x to the 5th, and the second logarithm I'm going to write as a logarithm base 3 of z squared. Done with the first step, and now I need to use the rule that I haven't used yet. I'm going to use the add to multiply rule to make the two logarithms into one, and I'm going to get the log base 3 of x to the 5th times z squared. If you had a teacher that's a little more picky than I am, you might have put this in a parentheses. I don't remember the Accuplacer exam having the parentheses, but they're probably better to put in than not, but more often than not, mathematicians with logarithms don't show a lot of parentheses. They get lazy, even though maybe they're proper to show. Okay, so hopefully you're still with me. Another one of the theoretically odd problems that's not particularly hard. Again, if I wasn't in grad school, if you gave me this problem, I wouldn't understand the problem or have any idea how to solve it. And another problem like this on the Accuplacer website, it has fractions as opposed to something with a negative exponent. So I just wanted to see a variety of this kind of problem. Again, it's not a particularly hard problem once you understand the question and know the trick. And there are many ways to solve this, and I'm kind of skewing towards the easiest way that I can think, even though maybe it's not the most theoretically elegant way to present the solution. It's probably the most tolerable. So the question says, if I pick two numbers, call one of the numbers A and one of the numbers B, where A is smaller than B, is f of A less than or less than B or not? So to do this problem, I hardly even explained it, but I need to pick two numbers, and I'll call one A and one B. And then as I go through the problem, hopefully I can explain it better. What has to be important of these two numbers is A has to be less than B. So what I'm about to do almost feels like it shouldn't even be legal, but to solve a multiple choice test, I don't need to get that theoretical in my approach to getting the answer. And if I'm more concrete, it probably makes it easier to follow. If I try to do the theoretical answer, it would be just ridiculous. I mean, some students might understand it kind of barely, but it would be kind of insane for most of you. So I'm going to say, for ease, A equal to 2, how about B equal to 3? Doesn't matter what I call A and what I call B. You can do 0 and 1 if you want, or you can do negative 17 and 240 if you care to. 0 and 1 might actually be nice. Let me maybe do 0 and 1. It'll make it probably easier. So it doesn't matter which numbers I pick. I can pick any numbers for A and B, just as long as A is less than B. And as I started doing math in my head, I'm like, oh, 0 and 1 is actually much more clever than what I'm about to do, I think. So I picked one value for A and one value for B. Now I have to compute f of A and f of B and compare them. Theoretically, f of A would be 2 to the negative A, and f of B would be 2 to the negative B, because I would just go to that x, and change them to A or B. But that's not what I want to do for this case. I want to put 0 in for A, and that would give me 2 to the negative 0. And I'm going to plug in 1 for B. That would give me 2 to the negative 1. So again, this still might be a little bit garbled, but once I pull it together, hopefully it makes sense. So f of A, which is f of 0, is 2 to the negative 0. That negative sign is the opposite of 0. The opposite of 0 is 0. Anything to the 0 power is 1, so f of 0 is going to be 1. And on the right side, f of b has is 2 to the negative 1, which is 1 over 2 to the first. So f of b is 1/2. Now I'm supposed to see if f of a is less than f of b. And I'm going to answer yes it is or no it isn't. Well, f of a is this line here. F of a is 1 because f of a is f of 0 because I made a equal to 0, and that simplifies to be 1. Now I'm going to look at f of b, and f of b is, for me, I kept writing b. I should have started writing 1s, although it's not wrong that I kept writing b's, but I changed the b to 1. I might as well write the 1. So is f of b is f of a less than f of b? For my a, f of a turned out to be 1. For my b, f of b turned out to be 1/2. If you pick different values for a and b, like the 2 and the 3 that I started with, you'd get different numbers down here, but the result's going to be the same. Either this is going to be a true statement, and I'll answer yes, or it's going to be a false statement, and I'll answer no. When I look at this, 1 is not smaller than 1/2, so is f of a less than f of b? Answer yes or no. My answer to this is going to be no, because 1 is not less than 1/2. So I had to pick a value for a that's smaller than b, plug the value for a into the original problem, plug the value for b into the original problem, and see if my results, if the f of a is less than f of b. If it is, I'll say yes. If it's not, I'll say no. Do the same thing for 7b. So I'm going to pick two numbers. I'm going to call one a, and I'm going to call one b, and it's going to be important to make the a smaller than b, so I might as well do the same two numbers. I'm going to let a be 0 and b be 1. So f of a in this problem would be 2 to the x, there's no negative there, and f of b, f of a would be 2 to the a, then f of b would be 2 to the b, and for this problem my a is going to be 0, so my f of a is going to be f of 0, which is 2 to the 0. Anything to the 0 power is 1. My f of b is going to be f of 1, and that's going to be 2 to the first power, and 2 to the first power is 2. Again, I'm asked to see if is f of a less than f of b, yes or no. Well, f of a turned out to be 1. Is that less than f of b, which turned out to be 2? Doesn't matter which a and which b. I'm just comparing the f of a column to the f of b column and seeing if it's a true statement or not. In the last part, part A, was a false statement, but in this part, 1 is less than 2. So for my answer to part B, I'm going to say yes, it is true that f of a is less than f of b. On the Accuplacer practice test, there's one of these with a fraction. Good one to look at too, because it definitely will. You can solve it exactly the same way, but you'll have to be able to work with fractions and exponents. And if you pick 0 and 1 for your a and your b, it shouldn't be that hard, because anything to the 0 power is going to be 1. Anything to the first power is itself. So hopefully, when you try the Accuplacer practice test, you remember this and you rock that problem. And then if you see something like this on the Accuplacer test, then maybe you rock it again too. 8, I believe, is on the Accuplacer practice test. And when I first looked at a problem like number 8, I was like, wow, I had no idea how to solve it, to be honest with you. And it took me a lot of thought before I figured out a nice way to explain how to solve this. So this is another one of those, the third of our first 8 problems that I'd call theoretical, that aren't particularly hard, but how the heck would you know how to solve this or even understand the question well enough to answer it without being shown. So in order to solve number 8, I will do some things that won't feel like even legal, but they're legal and really kind of an elegant way to attack this problem. In order to solve problem 8, I'm going to use this theorem. I think it's a corollary to the fundamental theorem of algebra, and the theorem that I'm going to pull out is that it says an nth degree polynomial has at most n solutions. Hardly looks like n's there. This is an n, that's an n. This theorem doesn't technically apply to how the problem is written, but I'm going to take the problem that's written and transform it into something where this theorem works. And what this means is something like this. This is something like 8x cubed plus 5x squared plus 6x minus 1 equal to 0. This is a third degree polynomial. I should probably say an nth degree polynomial. I should tack in the word equation there, because you need an equal sign to have solutions. This would have at most 3 solutions because it's a third degree polynomial. Something like this, if I did like 4x minus 5x to the 6th plus 7 equals 9x squared plus 2x. This is a 6th degree polynomial because the highest exponent I see is 6. It's a polynomial equation. It has an equal sign. This has at most 6 solutions. So ultimately, this is the theorem that I'm going to use. I think it's a corollary to the fundamental theorem of algebra, but when I poked around the internet trying to find the name of this theorem, I just couldn't find it. So again, I can't imagine anybody that didn't have a lot of math that would either know this theorem and have any reason to use it in this problem. But this is the theorem that is going to make this problem solvable, and again, not particularly hard. That's the case for a lot of these Accuplacer theory questions. If you know the theory, it's not particularly hard, but we don't teach this kind of theory, at least in the way that Accuplacer wants you to know the theory. So this problem, what's the largest number of points of intersections between the x plus y cubed equal to 5 and a quadratic function? That's a heady problem. So I'm supposed to intersect the function x plus y cubed equal to 5. This is a given function. And I'm supposed to intersect it with an arbitrary theoretical quadratic function. Intersect with some quadratic function. And then when I intersect them, I'm supposed to theoretically tell you what's the most number of solutions I can have. Basically, it says if I graph this function and I graph some quadratic function, which is a parabola, what's the most number of places those graphs could intersect? And that's a hard question to answer. So in order to get the theoretical answer, what I'm going to do is I'm going to make up an arbitrary quadratic function, and it will lead me to the answer that I need to get to. And so I'm not given a second function, which makes it really hard to figure out how many points of intersection that they have, because if I had 2 functions, I could graph them and count the number of points of intersection, but I can't. So I'm going to make up an arbitrary quadratic function and a really easy one. That's a quadratic function. It's quadratic because it has a squared term. What I'm going to do is take the 2 equations, the equation that they gave me and the equation that I came up with, which was a quadratic, and I'm going to condense them into one equation by replacing the y in the top equation of the given equation with x squared. This is kind of the algebraic way to intersect 2 equations. Just substitute from one equation, from the bottom equation to the top equation. It's kind of intersecting them algebraically. And when I do this, I need a parentheses, and I get x plus instead of y cubed, x squared cubed equals to 5. Now I have to know that I need to multiply those exponents to clear the parentheses that I put in. The number of solutions to this equation is the number of points of intersections between these two equations, and it turns out to be the largest number of solutions possible. So theoretically, this has at most 6 solutions. The largest number of points of intersections is the largest number of solutions to this. The largest number of solutions to this is 6. So the answer to problem 8, there are at most 6 intersection points between the given function and any quadratic. And I'm not sure that's a stellar explanation. Sometimes when you don't usually teach a topic, it's kind of hard to teach, and that's what's kind of hard for me. For whatever reason, I didn't do an 8a and an 8b. I don't know why, but number 8 was supposed to be like 8a, and number 9 is supposed to be my 8b. So sorry about the mess up on the numbering here. So when I do part 9, I want to find the theoretical largest number of intersection points between the same x plus y cubed equal to 5, and what I'm intersecting is an arbitrary cubic function. And my arbitrary cubic function, so this is my given, my arbitrary cubic function I need to make pretty easy, and my pretty easy cubic function is like my pretty easy quadratic, just y equal to something with the right exponent. To be a cubic, you need an exponent of 3. And now I'm going to take the y in the original function that's given and change it to x cubed. That'll transform this into something that will help me answer the question. So I'm going to rewrite the two equations as x plus x cubed equals to 5. This will give me x plus x to the 9th equal to 5. That's a 9th degree polynomial equation. It has at most 9 solutions. So the largest number of points of intersection between the given and an arbitrary cubic is 9, because that's a 9th degree polynomial. Kind of have to be in a theoretical math class, I think, to get problems written more like this. It's not kind of the vibe of what we do definitely in our college algebra, and not even so much in calculus. Okay, getting towards the end of this video. In this video, we just have up through problem 11, and then I do the rest in the second video. And for problem 10, I'm given 2 points and asked to find the slope of a line. I have to remember the slope formula. The slope formula, when I'm given 2 points and asked to find the slope of the line that connects the points, is m equals y2 minus y1 over x2 minus x1. And in words, the slope of a line passing through 2 points would be the y-coordinate of the second point minus the y-coordinate of the first point. That's y2 means y-coordinate of the second point, y1 means y-coordinate of the first point, divided by x-coordinate of the second point minus x-coordinate of the first point. So I don't know if this is insulting, but I got to be somebody that didn't know what y2 and y1 and x2 and x1 meant. So to do the next problem, I need to use the slope formula, and it turns out that the points are interchangeable. It doesn't matter which point you call the first point and which point you call the second point. You'll get the same slope. But when I go to do a problem, I usually take the first point and call it first point, and the second point given and call it the second point. So the first point given is the point W0. The second point given is the point 3t. And the instructions say find the slope. Probably find the slope of the lines. So m is going to be y-coordinate of the second point, which is t, minus y coordinate of the first point, which is 0, divided by x coordinate of the second point, which is 3, minus x coordinate of the first point, which is w. And the only thing that's going to simplify is the numerator. T minus 0 is t. The denominator doesn't simplify. You could write it with a w first and factor out a -1, but I'm not going to take the time to do that. They don't get that crazy in the simplifying in the Accuplacer test. So hopefully you've made it this far, and hopefully you go on and do the second video. It's going to be another hour and a half of your time, but it'll definitely, at least I hope, it will help you score higher on the Accuplacer test, which is kind of why you're doing this. It's not going to, prepare you at all, for your next math class. I mean, maybe a little bit, but it's not going to, make you all of a sudden an awesome algebra or calculus student, but it's at least get you into that class. For whatever reason, I have a hard time writing S's and 5s that look a lot alike. So that's an S, that's a 5. And when I go to find the slope, I'm going to use the same formula. I'm going to take the y coordinate of the second point, which is 5, minus the y coordinate of the first point, which is 0, divided by the x coordinate of the second point, which is 2, minus the x coordinate of the first point, which is s. And just like the last problem, the numerator is going to simplify, but the denominator doesn't really simplify unless I want to write the s first. So it's going to be 5 over 2 minus s for the slope. One more problem, that's not a particularly hard problem, before we pause the video and move on to the second part. So 11 is just getting used to function notation, and I'm asked to find f of 2, write my answer as fractions. I think both of these come out to fractions. To find f of 2, I just change each of the x's to 2 in the problem. And in this case, when I change the x to 2, I have a 2 minus 3, and 2 minus 3 turns into -1. And I should remember that negative exponents turn into fractions. 3 to the -1 power is 1 over 3 to the first power. And my answer to 11a is going to be f of 2 equals 1 over 3 to the first power. I don't need to write that exponent of 1, so I'm just going to write 1/3. Move on to part B, and then you can take a break or just keep going. So part B wants me to do f of -5. F of -5 is going to be 2 to the -5 plus 2 power. The numbers in the exponents have opposite signs, so I subtract and take the sign of the larger, so I get 2 to the -3 power. To make a negative exponent positive, I create a fraction with a 1 in the numerator. So I get 1 over 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. So the answer to part B, f of -5 is 1/8. So that's everything for the first half. I really encourage you to sit through and find the time to watch the second half before you go in and take the Accuplacer test. And like I said, if you can watch my 2 videos and then find some videos to show you or do the problems on the Accuplacer website, that should prepare you well enough to get into the class that you're kind of ready for, and that's all my goal is. There's definitely probably no way to do one massive review to completely prepare for the Accuplacer test, because it's just too varied from test to test, but this should definitely get you at least the points hopefully you need to get in the class you're trying to get into.